Hi, in this video I'm going to guide you through how you can assign pods to particular nodes. For example, you need to run a pod on the node with GPU. Let's start with NodeSelector. It is the simplest way to constrain a pod to run on the chosen node. How to do it? First, have a look at the names of the nodes and then add a label to your node. After that, add NodeSelector to your pod. Apply the manifest. Finally, check the result. The pod is on worker 1. As you noticed, labels play a key role in this process. The second option is Affinity and Anti-Affinity. There are three types: Node Affinity, Pod Affinity, Pod Anti-Affinity. In turn, Affinity and Anti-Affinity can be hard and soft. I'll explain it later. Let's look at Node Affinity. Node Affinity is similar to NodeSelector, but it's more expressive and flexible. In the example, this Node Affinity is equal to the shown NodeSelector. As I mentioned before, there are two types of Node Affinity: hard or required and soft or preferred. You can define the hard rule in the section required during scheduling, ignored during execution. It means the scheduler can't schedule the pod unless the rule is met. If any node doesn't have the label mylabel foobar, the pod will stuck in pending status. If you specify multiple terms in NodeSelector terms, then the pod can be scheduled onto a node if one of the defined terms can be satisfied. If you specify multiple expressions in a single match expressions field, then the pod can be scheduled onto a node only if all expressions are satisfied. You can define a soft rule in the section preferred during scheduling, ignored during execution. It means the scheduler tries to find the node that meets the rule. If a matching node is not available, the scheduler still schedules the pod. By the way, the phrase ignored during execution means if the node labels change after a pod is scheduled, the pod will continue running. As you see, there is a field operator. This field affects the logic of the node affinity. For example, is there a label on the node? The opposite, is not there a label? Possible options are on the screen. You can see additional field weight. If two possible nodes match the soft rule, the scheduler considers the weight of each node and adds the weight to the other scores for that node, and schedules the pod onto the node with the highest final score. Let's consider what the score means. To do it, we need to understand how kubescheduler works. Kubescheduler is the default scheduler for Kubernetes. The Kubernetes scheduler is a control plane process that assigns pods to nodes. Kubescheduler selects a node for the pod in two steps: filtering and scoring. In the filtering step, scheduler finds nodes where a pod can be scheduled. For example, there are enough resources on the node. These nodes are called feasible. In the scoring step, the scheduler ranks feasible nodes. Finally, the kubescheduler assigns the pod to the node with the highest ranking. If there is more than one node with equal scores, the kubescheduler selects one of these randomly. Let's go ahead. Pod Affinity and Anti-Affinity allow you to constrain which nodes your pods can be scheduled on based on the labels of pods already running in the cluster, instead of the node labels. Syntax is very similar to Node Affinity. In the example, there is the pod with the label mylabel foobar on the node worker 1. So my pod will be scheduled on the node worker 1. In Pod Affinity and Anti-Affinity, there is a topology key field. It is essentially a label key that identifies a specific aspect of the physical or virtual environment, such as an availability zone in the cloud, rack, or host. In the example, the pods will be spreading across hosts where there are pods with the label mylabel foobar. You can find more examples in the official documentation. By the way, Pod Anti-Affinity requires nodes to be consistently labeled. In other words, every node in the cluster must have an appropriate label matching topology key. In our example, the label is kubernetes.io-hostname. If some or all nodes are missing the specified topology key label, it can lead to unintended behavior. Pod Anti-Affinity is similar to Pod Affinity, but works vice versa. For example, there is the pod with the label mylabel foobar on worker 1. So my pod will be scheduled on master or worker 2. It can't be scheduled on worker 1 because there is a pod with a label that is specified in pod and Affinity. Lastly, I want to tell you about tolerations and taints. In simple words, the mechanism of taints and tolerations is the opposite of node affinity. It allows you to restrict running pods on the particular nodes. The best way to understand it is to consider an example. First, I am adding a taint to the node worker 1. Then I am checking it. I have added the label mylabel foobar on node worker 1 before. The mechanism of taints and tolerations doesn't guarantee that pod will be scheduled onto a particular node, so I've specified this label in NodeSelector to run this pod on worker 1. For scheduling the pod on worker 1, I must add the toleration to the taint. Toleration works like an antidote to the poison that is a taint. I am applying the manifest with the pod and checking the result. To conclude, pods without toleration can't be scheduled on worker 1. As you noticed, there is an effect field in the toleration section. You can choose 3 options. No execute. This effect blocks non-tolerant pods from being scheduled on the node and evicts any running pod on the node that doesn't tolerate the taint. No schedule. No new pods will be scheduled on the tainted node unless they have a matching toleration. Pods currently running on the node are not evicted. Prefer no schedule. It is a soft version of no schedule. The control plane will try to avoid placing a pod that doesn't tolerate the taint on the node, but it isn't guaranteed. That's it. I hope this video was helpful to you. Don't forget to push the like button and subscribe to the channel. See you in the next video.